Hello, welcome to another tutorial. In this video, we'll be going over how to run your AUBO Python SDKs. Now, the first step, once you get your Python SDK folder, is you want to go into your dynamic link library folder, DLLS, and copy every single one of these files into your native Python 3.7 folder. So, you're going to want to go into your drive, under users, your name, app data, and notice app data is a hidden folder, so you're going to want to go into view, show hidden items. If you can't find it, you must select hidden items so that this app data can show. App data, local, and then you should go into programs, which is right here, and Python 3.7, and please note that you must be using Python 3.7 for this to work. And go into your DLLS folder and paste it in here. As you can see here, I already have pasted it, so I don't need to do it again. Alright, so now we have copied all the DLL files into the native Python 3.7 DLL folder. We can get started and run some examples. So we can open our robot control.py file. And inside this file, there are many examples and many defined functions you can play around with and explore. So we'll be going over three examples today. And to run a function, you just basically put the function call in this last if statement at the very bottom of the file. And when you run this file, this function will run. So let's start off with this test process demo. So this test process demo basically comprises of is composed of three move joints in a while loop. So first, we ensure we're connected to the robot through this IP address, and this IP address again can be found through your AUBOPE software under settings, system, network, and click ifconfig, and you'll see that this is your IP address that your connection is based on. So make sure that this is the same IP address. And after that, you just set some joint maximum velocities and as well as accelerations, and set a blend radius. And here we just define three sets of joint angles for the robot to move joint to. And it is inside this while loop, so until it will keep on going forever until we have a keyboard interrupt, or we just close the command window. So now let's run this and see what this looks like. So to run this, open up your command prompt. Now you're going to want to cd into the folder where your robot control.py file is located. For me, it's in here. Sorry. So cd into this folder. And now you can call Python robot control.py to run this, and it will run. So now as you can see, the robot is going to move between the three sets of joint angles. Now we can end this by clicking any key on the keyboard. Next, let's run this test function. So comment the first function out and then uncomment the second function here. So we have an input parameter of 2, so let's see what this means. So this test function, it takes in test count as a parameter. So before we go to that, let's take a look at what happens first. So we, again, initialize the IP address so we can connect to the robot. Here, while test count is greater than 0, I will go into this loop, and every time it loops, you'll subtract the test count by 1, meaning this is the number of times we'll actually run this function. So we first start off by setting some maximum joint accelerations and velocities. We move to a very initial position. And we here just shows that we can do forward schematics as well as inverse schematics using SDKs as well. Move to a second location. And we have two more move joint commands here. So just moving to some waypoints. Here we set the maximum tool end velocities and acceleration. Now we define 3 waypoints. 1, 2, 3 here. And the purpose of this is for our move track, which is a circle here. So we want to move in a circle, and to define a circle, we must provide 3 points. And we're looping through the circle 3 times. So when the robot is moving as a circle 3 times. Finally, it's moving back to the 0 position. And it will do this whole process twice. So now let's run this and see what this looks like. Save this file. Again, run Python robot control.py. And I'll start drawing the circle 3 times. And I'll reinitialize and do this whole process again. And now, once the robot finishes this whole procedure twice, the whole project will end. Now, let's take a look at one more example. Let's take a look at this test RSM example. So this is basically showing how to set your digital output I/O pins. So here, while it is true, we're just setting the I/O pins of the digital output 2 to 1. We're setting the status of this to 1. And we wait for 2 seconds, and then we set the same I/O pin to 0. So we're just turning it on and off every 2 seconds. So this is just a basic demo showing how to, adjust the states of your I/O pins here. Now let's run this. Open up our AUBOPE software, go into I/O state, user I/O. And now you can see here through this blinker that this DO2 is turning on and off every 2 seconds here. And you can see the same thing through this command window. And again, you can stop it by using a keyboard interrupt. And there you go. Those are 3 basic demos that can get you started playing around with the Python SDKs, and feel free to explore the other examples as well. If you have any other questions, feel free to contact AUBO support.